Hi, so if there is nothing more than is proof of that, you open a door and there are surprising other doors to open and you can find all kinds of things, this mushroom exploration we're going on has to be exactly that, because of course I'm researching some of the ideas associated with these things just out of interest, and we've come across some really quite surprising things, but this one, I have to say, beats the pants off of anything else. It's astonishing. There's a big problem in the world today, and that is water. All you have to do is look at the fires in California, the droughts in Texas, and you realise that water is becoming quite a scarce commodity. Actually, it's fresh water because of course we've got a ton of seawater. The problem with seawater is you've got to take the salt out, and that is really energy intensive, and that makes it quite expensive to desalinate seawater. So getting fresh water from seawater is a huge challenge the world over. And desalinating spoilt water and groundwater that's got too much salt content is another huge challenge the world over. And what it's led to is the idea that solar steam generation would be able to answer those questions if we could find an efficient way of doing it. Now, solar steam generation is just the sun heats a surface, absorbs that heat, light energy, turns it into heat, and that will boil the water. Now this happens naturally, it happens just on the oceans, and it's a certain rate. It's about 0.5 kilogram per hour or something like that. I'll check that figure. But a group of scientists asked themselves a question, and who knows why they asked themselves this question. Probably because, like me, they were just interested in mushrooms, just like I asked this question. And they found that this thing is actually ideal. It's got a number of qualities that make it ideal. It's got a structure with a very thin cross section. The top cap underneath, where it's white, is relatively insulating. This bit here is dark and does a great absorption of solar. Even though they spend most of their life on the forest floor, they're actually brilliant at absorbing solar across this cap here. This bit here will pull up water through capillary action like you wouldn't believe. So they got one of these, it's a shiitake mushroom as it happens, stuck it in a beaker of water and shone a light on it. Turns out this will do solar evaporation at something like 2.5 times the efficiency of direct sun on water. And it does that because of the unique shape and structure of a mushroom. It's able to suck the water up through here. It's able to spread it through there without losing heat, and then it's able to evaporate it off the top of there because that is an efficient solar collector, which is astonishing because mostly, of course, these are used for food and they live in dark conditions. So the fact that that can do that so surprisingly efficiently, it's around about 78% efficiency that it does it, and about 2.5 times better than just shining it directly on water, is clearly an amazing result, and is opening doors to how we could create efficient solar steam for things like cheap desalination to help with the world's water problem. Now, some folks have used this as a springboard, obviously, and they've looked at the structure and said, okay, how can we replicate that structure? And what they've then done is carbonize the mushroom. Because when you do carbonisation, remember, you maintain the structure of the mushroom, as we've seen in things where we've done mushroom supercapacitors, but you make it black. And of course, there is no better colour at absorbing solar than black. So they've taken this stuff, carbonised it, put it into a disc, and then floated it on a piece of wood, and found that they have this incredibly efficient solar steam generator for things like desalinisation, based on mushrooms. Now then, we have two things from previous experiments that are going to help us in doing this to see if we can make an efficient solar evaporator. What we've got is some mushroom carbon that we made when we made a mushroom supercapacitor and charged and discharged it. It's just mushroom carbon in a binder. And we have this stuff. This is Oasis. Oasis actually is amazing stuff. It will suck water up like you wouldn't believe. So we're going to cut off some of this Oasis, paint the top with carbon, put some little legs on it, and that should be our solar evaporator. So let's get on with that. So here is my artificial mushroom. Now I've got thin legs, just like we'd have in a mushroom. We've got the cap, and I've painted it with our mushroom carbon. And here I've got some water. If I stick that in there, then the water will get sucked up through the oasis to this top part here. And we pop that in the sun. We can weigh that and see what that is to begin with, and then weigh it over time and see how much is lost by evaporation. Because we also need a control, which would just be a tray of water, exactly the same size and exactly the same weight. And now all we need to do is stick that in the sun and give it some time. That was somewhat awesome. Over about 4 hours, it did in fact evaporate roughly twice as much, which is pretty cool and pretty much in line with the research. Now, if you are interested in this, all you've got to do is go to Google Scholar and put fungi, solar steam, desalination, and you'll find a whole host of papers where they've been looking into this. And obviously, this is a real issue in the world, and so if it's something you wanted to work on, then it would certainly be something of great value. Anyway, I thought I would share that idea with you and my somewhat rough and ready experiment. I hope you enjoyed the video, and thank you very much for watching. And please do remember to like and subscribe.